Simplify each expression. We have 4x plus 8 over negative x squared plus 4 and 9k squared minus 1 over 3k squared minus k. How do I simplify each of these rational expressions? Chloe is here with her latest cheat sheet notes. She wants you to know that when you are looking for domain restrictions, you cannot have a 0 as the denominator. Also, any value of x that causes the denominator to equal 0 is definitely restricted. Also, when you're dividing by same bases, you subtract the exponents. Now that we have Chloe's cheat sheet notes, we can go ahead and simplify each of these rational expressions. On the first one, we have 4x plus 8 over negative x squared plus 4. Anytime I have a coefficient in front of the x squared that is a negative, I always like to pull it out in front. So you'll see that I pulled the negative out, and that leaves me with x squared minus 4. Negative 1 times x squared would give me negative x squared. Negative 1 times negative 4 would give me a positive 4. I always do that because it makes it a lot easier for me, and I would suggest you do the same thing. In the numerator 4x plus 8, the greatest common factor between 4x and 8 would be the 4. So I pulled out the 4, and that leaves me with the quantity x plus 2. 4 times x is 4x, 4 times 2 is positive 8. From here, I'm going to go ahead and break down this x squared minus 4, this quantity that I have here. I need to go ahead and figure out how to factor that. Now, always what you want to do is ask yourself, do I have it in standard form, which is ax squared plus bx plus c? I have the x squared and I have the minus 4, but I do not have the part in the center. But there really is a part here. It's just 0x, because 0 times anything just gives me 0. So if I have x squared plus 0x minus 4, that's the same thing as the quantity x squared minus 4. So when we are multiplying these to go ahead and figure out, when we're ready to factor these, we multiply the leading coefficient and the constant by each other, and then we take those same factors and we have to add them to get the one that's in the center. So I like to use a little chart here. You can see that 1 times negative 4 gives me negative 4. All the factors that can give me negative 4 are 1 times negative 4, negative 1 times 4, and 2 times negative 2. Then I have to add those factors together and I want to equal 0. So 1 plus negative 4 is negative 3, negative 1 plus 4 is 3, and 2 plus negative 2 is 0. Which one multiplies to negative 4 and adds to 0? That's when we have the factors of 2 and negative 2. So because my leading coefficient on this problem was a 1 right here, we do have a 1 as a leading coefficient, we can just go ahead and split that into the negative in front, because we still have that negative 1 in front, x plus 2 times x minus 2. In the numerator, we have 4 times the quantity of x plus 2. Now, what do both the numerator and denominator have in common that I can cancel out? Well, when I'm looking at this, I see that both of them have that quantity x plus 2. So I can go ahead and cancel that out of each of them. What does that leave me with? That leaves me with 4 over negative 1 times x minus 2. Now from here, I'm going to go ahead and distribute that negative back through into my problem. So I end up getting negative x plus 2 in the denominator. So my final answer is 4 over negative x plus 2. Now let's look at our second problem. Our second one is 9k squared minus 1 over 3k squared minus k. Again, we're going to go ahead and pull the greatest common factor out of the denominator. 3k squared and k, we can pull a k out of each of those. So that would be leaving us with 3k minus 1. K times 3k is 3k squared. K times negative 1 is negative k. Now in the numerator we have, let's write it up here, we have 9k squared, and then we have minus 1. We don't have the b part in the standard form, but we know that plus 0k would give us that. So we can see here on this one, all we have to do is figure out two numbers that multiply by each other to give me negative 9, but add together to give me 0. So I went ahead and made this into a chart, and you can see here that we have, when they're multiplied, it's 9 times negative 1, so it's negative 9. What two numbers multiply by each other give me negative 9? 1 times -9, -1 times 9, and 3 times -3. And then the number in the middle was 0. So which ones add up to give me 0? And you can see our answer is +3 and -3. Now, because the leading coefficient on this problem was a 9, it was not a +1, we cannot just split it like we did x plus 2, x minus 2 in this other problem. We're actually going to have to take that 9k squared plus 2, 9k squared minus 1, and split that into the grouping technique. So when you do this, you will notice that the plus 3k and the minus 3k are in the center. The 9k squared and the -1 didn't change at all, but you have to add the 3k and -3k in the center. When you add those up, it equals 0k, so they cancel each other out. But when you have a coefficient that is anything other than 1, you have to use the grouping technique. So my next step on this one would be to group the first two together, group the last two together, and put that positive sign in the middle. Now I'm going to pull out the greatest common factor out of each of these terms. So the greatest common factor on this first one is 3k, which leaves us with 3k plus 1. And on this last one, all I can pull out is that -1. Now I didn't really write the 1 here, but there really is a 1 here. So if you want to write the -1 there just to help you, go ahead and write that in. From here, you can see that both of them have this greatest common binomial factor of 3k plus 1. They both had this 3k plus 1. So I went ahead and pulled that 3k plus 1 out in front. What did that leave me with? My remainder was that 3k minus 1. So that's our second part here. So now I'm just going to go back up to my original problem I was working with and add that 3k plus 1 times 3k minus 1. Now look at your numerators and denominator in this problem and ask yourself, what can we cancel out of both of these? They both have the 3k minus 1 part, so I can go ahead and cancel that out of each of them. And that leaves me with my final answer of 3k plus 1 all over k.